Bum 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 bum.
Tomatoes?
Hello, welcome to video 4, Unreal Concepts, a dynamic circular progress bars. This is actually a follow-up to a previous video, which will be linked somewhere on the screen, depending on where I plan on putting it. Just look for something that's flashing now, maybe. And the previous video covered how to make progress bars that are a circle, as well as dynamic progress bars in terms of non-circular shapes. And if we were to go over here and we looked at a progress bar, the original progress bar that we were using is a circular progress bar here. And it basically can circle, and that was it. Now, based on not covering previously some of the other nodes to allow more robust features, now that they are covered, I can go ahead and do a follow-up, an addendum, and basically show how you would iterate and expand upon a concept. So this is a concept video about a concept on expanding a concept. So it's conception. Now, if I hit play, on the bottom left, we'll see some really, I think, cool looking progress bars. Those are actually technically 4 different progress bars, even though it looks like 3. We have them dynamically going up over time, just so I can show you. But we have like the bottom one that looks like it's going from the middle out, and then we have the other 2 going up. Now, if we were to go over here, we're going to see our original progress bar right here, basically using the new code, but that's what the old one did. If we remember back to the old video, I had an issue where I told you if I didn't use 1.1 as the full value, it would kind of leave a little bit of a gap. And that's because we were using a gradient. We were using this angular gradient, which was imported in from an external program. And it could have artifacting, it could have compression issues. As you can see, you know, it's not the smoothest thing in the world. And we had some problems due to that. Now, I am not an artist, so my goal is to try to solve things without using art. I should try to do everything programmatically if I can, and that is what this video is going to cover. Let me hook this back up. This is our old one. This is where we used our dynamic angular gradient. And this is where we used our texture. And when I run this, I don't think I hit compile, actually. Yeah, I didn't hit compile. I've got to remember to hit compile. There we go. We'll hit compile. We'll let our shaders compile for a second. We'll go ahead and hit play, and we'll go back over here. And now you notice the one on the bottom left obviously has problems because it's broken. But if you look at the one on the top, you'll see that little spot I mentioned. And that's because, again, this is our old system, and we're using a texture, basically flipping our texture, which is giving us a little bit of our dash here. And then we're using the alpha to drive if it's above or below, based on our circle. Now our new system is right here, and this one uses actual math in order to figure out and give us a smoother gradient. If you notice here, this is the gradient we will be using, and this is the gradient we were using. And as you can see, it's a little bit better, in my opinion. It definitely has more appeal to it. So let's look at how this works. What we're going to use for this is a custom rotator and a vector to radial value node. What these do is the custom rotator allows us to rotate the UVs that are input and then give us back a rotated value. And this is covered separately. The important part here is I'm actually adjusting these using parameters to give me a starting point. Now, what do I mean by a starting point? Well, let's look at one of our... let's go back again and apply our changes. Then go back into our dynamic material, and we'll have access to our options here. So what this means is, let's not adjust that one actually here. Let me make another duplicate. There we go. Dynamic progress bar sample. There we go. I don't want to adjust the ones I'm using because then I break everything. Did I duplicate? Yep. Okay. So let's delete the duplicate, and let's create an instance. There we go. And now we have what we want. So with our default settings, it functions the same. We go from the top and we go around. And we have a nice little smooth, as you can see. 0.5 is exactly where you'd expect it, halfway. 1 is complete, and 0.25 should be where you expect it. Now, the ability to make this dynamic is our extra options here. We have a clockwise option. Well, if we check it, it goes clockwise. And if we uncheck it, it goes counterclockwise. Pretty simple, but nice to extend to your game designer. Let's go back to clockwise, and we'll go ahead and run like that. Our next one is going to be our starting point. This one's kind of cool. Let's run this at halfway. Now let's say I wanted, instead of a vertical progress bar, I wanted a horizontal progress bar. Well, we can change our starting point to adjust for that. So if we want it like this, let's say 0.25, we now have a bar that goes and fills up like that. Kind of cool, right? And that starting point is adjustable on the entire 360 degrees. So if we adjust it to 1, we now have a bar that goes, well, it's identical before because we're back at the beginning. But if we did it halfway, the bar now basically goes from the bottom instead of the top. And it's completely adjustable for your starting point. Now let's undo that and let's go with our complete range. Now complete range is pretty cool. Basically, let's say you wanted a bar that only goes halfway. You only wanted this to represent full. So something like 0.25 should represent, well, technically 0.5 should represent half. But if you do 0.5, obviously it's going to represent half of a full circle. So when we change the complete range value, we change it to the percentage of the complete circle that we want to be shown when your alpha, or your 100% completed, is full. Let me show you that in an example. I want this to be my full range. So I change my complete range to half, and now when I change my alpha, it'll only go between empty and full. So now if I was to, for example, to pass in 100% or 1, it's only going to fill up to that point. And the design of this is so that way the designer, coder, whomever is doing your back-end logic doesn't have to do the math in the code itself. It's all done in the shader. It's done in the material. They don't have to think, well, let's see, I have a progress bar that's only this size. It's meant to just do a small little thing. However, what percentage is if they're at 0.5%? Well, I need to do some math and do some more. No, you don't. You flip in your alpha. I'm at 50%, 30%, and it automatically fills it in appropriately, as you can see here. You set your maximum, and then you set your current value. And of course, your starting point is, again, completely adjustable, and that gives you all your funky little options here, which of course allows me to do what we have here for our example. If I close this and close this little example here, I basically just adjusted my materials. If we go into, for example, our first one, we'll find our first one here is set to this, which is 0.165 for a complete range, or half of a third. Starting point is going to be halfway, or 0.5. I want to start at the bottom. I want to go clockwise, and then as you can see, it's just basically going to fill up this small part here. And if we were to go to the bottom two, you're going to see, because it's not clockwise now, it's going to fill up the other direction. So by running these two together, it's basically going to start from the bottom and go out towards the edges. And our other ones, of course, are similar. Our left one is just simply a third with a starting point of a third. And our right one is a third. Well, it's technically 0.339 with a starting point of 0.6. I had to do that because if I did 0.33, I don't really know why. I'm guessing due to rounding. You got this little bit of an issue here. So when I changed that to 0.339, it fixed the issue. If I can find where it went to. It fixed the issue. I've gone ahead and I have adjusted my bottom right one. Let's see. Bottom bar image 2. Oops. Let's adjust it. I moved my alpha so that way our example wasn't working right. There we go. Yeah, so it's just a little bit of an issue where things aren't quite working properly. And that's, again, this material is completely adjustable, so it's dynamic and you design it however you want. Going back to how everything's done behind the scenes, it is really ugly in here because, well, I designed it to be ugly because this was just an example, but it's following the same stuff we did in our first video. If we go into, let's close everything up. All we're doing here is getting a dynamic material for each of our bars and saving a reference. And then whenever we set the progress, we're simply setting the value on each of our bars based on whichever bar we press in. This is ugly. It's a concept. It's supposed to show that it can work, show you something pretty on the screen. In terms of how I'm doing it, I have my little health bar guy here, and he's doing some fantastically ugly code, as you can see here, which is pretty simple. All he's doing is if the health goes down, he's adjusting all 4 of the progress bars, and if the health goes up, he's adjusting all 4 of them in the opposite direction. And all we're doing here is changing over time, over 2 seconds, our bars to go from 0 to 1. As you saw in the previous video, this is the same thing, except I'm now changing all the bars at once instead of 1. Obviously, in a real game, you're going to want to have code backing this properly so you can adjust your things in real time. But the point of doing it like this was to show you it's working, it's dynamic, it's adjustable, and also a way to take something that exists and make something different. As we saw in our designer, our bottom images here, if we were to go ahead and hide these two, these are again 2 images. But because the material is designed in the way where it doesn't care, it cares in terms of the material on the values, but the way it's designed is when you set it up to say this is 0 and this is 1, this is 0 and this is 1, as long as you feed in the values, which I'm feeding in between 0 and 1, it's going to grow and it's going to look like it's 1 bar feeding out, even though it's 2. Now you probably could have gone in, made a material that did that automatically, but it's 1 extra material. It's probably used for something small, maybe an update every couple frames if you got hit. Maybe it's a progress bar or a damage bar. It's just intended for looks. And as you can see, it works. It gives you the illusion of a bar expanding out. And of course, I could make it bigger if I want to. I could make it go from here. Actually, you know what? Let's see about doing that. Let's go with... let me not break this because I don't want to, but let me just show you how expandable this is. So we'll go with 3 and 4 here. And 3 is going to be a complete range of 0.5, right? Yep, halfway. We're good there. And we'll save that one. And then we'll go with or 4. This one's going to be a complete range of half as well. We'll save that one. We'll go back into our item here. We're going to want bottom image to now be 3. Bottom image to now be 4. We'll take our left bar image and we'll simply hide it. I know I can hide it, right? Is visible? Can't I change an image to... It's visibility settings, right? Oh, right here, visibility settings. There we go. Hidden. I knew it was in there. And I'll hit play. And now you'll see. Same thing, except now it's filling up completely. And all I did was just adjust the settings and told it to go all the way up to 0.5 instead of our 0.165. So, it's super simple, super easy, super simple and easy to adjust. Let me put these back to how I had them, so that way when you download the example, you're not confused on why things broke. Hey, you know, let's try this. I'm curious what this one looks like. That's kind of cool. See, it's still filling up at the same rate over 2 seconds because of my timeline. It's going to 100%. Give me a little bit of a weird effect. Of course, everything's customizable. That's the whole point of this. And let me go back to this one is 2. Then let's turn these back on to visible. Okay, and we'll go ahead and save that. Now I know we were in the middle of going through the material, of course, and I broke everything as I explained it, but that was important to show how adjustable it was. And all of that was based on a few parameters we put in. The custom rotator is what determines our starting point, or where we're going to point on our 360 degrees or 0 to 1 rotation. I'm doing a little bit of funky math here. If we were to take our starting point of 0, it's going to start here on our far left. our starting point, can I start previewing this here? Yeah, it's going to start here. By adding 0.25 at the default, it changes it to start here, which is where I want it. And all I'm doing is basically allowing you to go from 0 to 1 and adding 0.25, so my starting point is always at the top, because that's how I want it. And of course, that is completely adjustable based on what you want. So again, we start here now. We go in here, we convert our customly rotated vector into a radial value. So it's going to convert it into this. So now we have our radial value at the top instead of sideways. We take that vector converted angle, and that's basically going to output it into a black and white version of this, a grayscale version, which will be right here. And I'm actually flipping that. Now I'm only flipping it once, and that's in our clockwise parameter here. So if we were to go here, and we were to look at this, you're going to see it's slightly different. You have black on this side and white on this side, right? And if I was to, darn it, move it, there we go. Let me put an add node here so I can show you just simply what I mean by different. And we'll flip these, and here we go, and we'll look at them. So here's your difference. This one technically can be plugged in a false, but I'm not going to. I am using a switch, and if it's clockwise, we're going to go clockwise. And if it's not, I'm not 1-minusing it or flipping it. So we have black on the left or black on the right, and I'm using a switch to drive what we're going to see. So that's why this is set up like that. So with a simple switch or a Boolean, we're able to flip it based on just inverting our grayscale. Now that is put into an add node. Now our add node basically will determine how much of our range is seen, which is our complete range here. 1 is our complete range. It's everything. It's going to not mask anything. And our alpha, which is our how much of the bar we see. So for example, we changed our complete range to something like 0.5. And then I refresh this. We're going to end up only seeing 0.5 or half of it because we're only allowing basically a quarter to show up. Remember, it's a multiplication. So if we go in here and we do 1 times 0.5 means show half. 0.5 times 0.5 means show 1/4. So we're only going to show a quarter now. That's why you're seeing this right here change. We have 1/4 being shown, or in this case, if we refresh, we have 1/2 being shown. We have 1 times 0.5. So by again using a couple more parameters, one of them drives how much we can see. One of them determines how much of the complete circle we want to use. One of them drives how much of that complete circle we want to see. And that, of course, is multiplied against our circle itself down here. Now our circle, I've changed a couple things on our circle. Technically, I didn't change anything, but I want to show a different option. In here, using our radial gradients, you could technically use something like a custom rotator and make your own circles. But I didn't. I'm using the radial gradients because I like how much control it gives me. But of course, the output is going to be lower colored, a low strength. So I'm using multiply to make it much more white. Now you might be thinking, well, why not use seal? So that way your whites are white and your blacks are black. The problem with seal is it's going to give you a very exact a 0 or 1. And it's going to cause a problem where you're not going to have smooth edges. And if we were to run this, I don't think I hit play. Oh, I did. Okay. You'll notice our gradient isn't as smooth looking as before. It's very rough because our edges basically have no built-in anti-aliasing. As you can see here, we have this smoother compared to this rougher. So that's why I like leaving that as a multiply, just to give me a nice smooth edge. And of course, you can multiply it based on how strong you want as well. If you went to something like 250, you're still going to get a very, very well-defined white border, but you're going to get a nice feathered edge on each side. I don't know. Let's see what 4500 does. See, now we're getting more closer to our inside there, which is probably not what we want. You could even bump it up to something like 1,000 is probably too much. 600. See, now it's not bad. Actually, we get a pretty smooth inside and a nicely well-defined outside as well. Wait for it to compile, of course. And there we go. And it's not as smooth, but it's not as bad as before. And of course, everything's personal preference. I'm going to change this back to 50 because I like 50. And then we'll get that. One last thing. In terms of this up here, this is just one of those things where you could do things how you want. And this is also to reiterate. We've accomplished everything I'm doing right here with the circular bar before. This is another way of doing it and expanding upon it. So here's another way of doing this portion right here. Taking our texture coordinates and using a bias scale with these values, -0.5 and 2.0, we're basically shifting everything down. And we're basically giving us these 4 separate squares. Or if you took your texture coordinates and simply multiplied it by 2, so you have a tiling, so you have 2 on the x and 2 on the y, and then you subtracted 1 from that, it's going to give you the same result. We can actually plug this in, and we're going to get our same result once it's done. Which one's more performant? Which one's better? I honestly don't know. This one is going to give you the ability to keep things consistent based on the input texture coordinates because you have a 1 for tiling. This one's going to give you more fine detail because you could go in, like for example, and do something like this and refresh, and you're going to get this weird result where things are off by a little bit, but you get partial circles instead of your half circles. So you can get kind of like a wiping or a fading effect. Whereas if you tried to do it with this one, if you changed your bias scale to like I did with 5, let's change the maximum to it in the meantime so I can fix it, and we refreshed it, your bias scale itself is going to give you back roughly the same, but it's not going to give you back the exact. As you can see here, we had 5 and 5, and refresh, and you don't get back exactly the same. Even though these are the same inputs, these nodes handle them differently. So again, up to your artist, play with the settings, figure out what you want. I'm going to go ahead and leave this as 1 and 1 using the bias scale because this will give me an exact center and give me the result I want. But this is just an example of doing the same thing 2 different ways. I think with that, we're pretty much going to wrap this up. And I'm just going to leave that as a mess. This is a concept video. It's meant to be messy. And again, we showed how we have a nice little adjustable, and we actually use the exact same code from before, and we have our existing circle. This is intended to be a follow-up to the existing video. I'll link it again above or below, or I'll pick somewhere. Maybe I'll put it all over the big screen so you have to click on it. But it's intended to be a follow-up to show you that you should continue iterating on things and try to improve them. And by trying to improve them, you may be able to make them better and easier to use and make them more accurate. The goal for me was to not use a texture. I tried to not use any external resources as much as possible. And by using these other nodes, which we see up here, I now do not have to use any textures, no texture memory, no external textures, no references, no having to make sure this is a smooth texture or it's coming in properly or my UI import settings, all of those headaches. I managed to figure out how to do it inside of the material shader itself and give it more functionality. And of course, because I keep forgetting to mention it, maybe one of these days I will remember, all of the source code is available in the description below. Just click on the link to go to GitHub and you can go ahead and review it as needed.